I was focused there. Which one? 58. Let's take a look. Yes, of course. It's not a variable. It's just a letter. Yeah, normally A, B, C, D, and they're just numbers. Yeah, we can have two variables in a limit like that. One of them has to be. Yes, of course. Yes. So we picked 56. Yeah. No, I'm sorry. 58. Yes, we picked 58. So this is limit. I think it's when x approaches infinity. Yes, it is. 1 plus a over x, everything raised to, is it bx?
Yes.
Okay, perfect. Very good. We have to plug it in. Of course, a and b are constants. What can I say? Since I got sick last year and just always freezing. Sorry about that. Okay, so let's plug it in. So where does this go? Careful. Let's take it step by step. Where does this go? 0. 0 plus 1. 1. Where does this go? Right. It's one of the three powers. 0 raised to 0, infinity raised to 0, 0 raised to 0, infinity raised to 0, and 1 raised to infinity. You can conclude it's one of the powers. Okay, then our only way, the only option is what? Yes. So first I have to write y equals 1 plus a over x raised to bx. I have to write this first. Then what do I write? Yes. Natural log y equals bx times natural log of 1 plus a over x. Good. Next. Yes, yes, of course. Now the limit. Yes, I was just waiting for you to say. Limit of this is limit of this. Ah, I didn't mean that. I'm going to erase that. So this is a product right here. Good. For me, white out is as big as electricity being invented. Good. So then, where does this go? 0 plus 1. Where does this go? Very good. Where does this go when x approaches infinity? Good. We made progress. From the insane power, we changed it into a product. That's a huge progress. You can say it's still not 0 over 0 or infinity over infinity. I know, but it's still a huge progress. Okay. Now, with one little manipulation, we can change it into either 0 over 0 or infinity over infinity. And no, we are not going to touch natural log. We can't. It would be insane. So then I have to do something else. How do I manipulate bx? Forget about b. I can even put it outside. I don't care for b. It's a constant. I can go outside and wait. So what will I do to bring something to the denominator without changing the function? Say it again. Of course, 1 over x. I'm really hoping now for 0 over 0 or infinity over infinity. Where does the top go? Yes, that hasn't changed. Where does the denominator go? Yes, exactly. Say it again. When you flip that, you get x at the top. You have to flip that to get x. Right? Because we divide by fraction. When we divide by fraction, we flip the fraction. Is that okay? Perfect. Good. So we are ready now. So this is b. Limit as x approaches infinity. Since it's 0 over 0, let's differentiate the top. Let's differentiate the denominator. That's the easiest thing to do right away. 1 over x squared. Good. So let's differentiate the top now. The inner function prime. Negative a over. Yes. Very nice. It really is. Because these two will go away and the positive a, because it's negative and positive a will be transported in front. So this is AB, limit as x approaches infinity from 1 over 1 plus a over x. And the answer for that inside is, for that limit is, careful, yes, it is 1 times AB. So all this approaches 1. Because a over x approaches 0 when x approaches infinity. 0 plus 1 is 1. 1 over 1 is 1. We haven't finished. I have to copy the beginning, and I have to copy the end. So limit of natural log of the function as x approaches infinity equals AB. What now? Yes, these functions are all continuous. Otherwise, we don't have a possibility to check the determinants. Very good. So we have natural log of limit as x approaches infinity from y equals AB. And the question is, what can this be? So e raised to AB. Because only natural log of e raised to AB brings AB in front. Natural log e is 1, and we get AB. You can't say that you expected this. I wouldn't ever believe it. So the answer is AB. Of course, E. Sorry. I rushed to write. It's E to AB, of course. Sorry about that. I shouldn't even write it here. I should write again the whole thing. It's E raised to AB, of course. There is nothing else that works.
All of these functions that have to do with swapping happen.
So it was limit as x approaches infinity from 1 plus a over x raised to bx equals e to ab. Good. Do we need another? We're fed up with this?
Isn't the limit of 1 plus 1 over x to the x e?
Is e, exactly. Yes. Exactly. Yes. Any questions? And there is one when x approaches 0 also, from 1 plus x raised to 1 over x is also e. Good. Do we need another, yes or no? We understand the mechanism. We've seen this before with logarithmic differentiation, correct? Because we could not differentiate tangent raised to secant. Right. Okay. So in that case, we should continue with the second application in this chapter. Now, I'm debating with myself. We're down to 25 minutes, roughly. Should we look at Newton's method, or should we look at optimization? These are the last two sections of this chapter. Newton's method? Okay, so in that case, let's look at 4.8, and we will look at 4.7 next week. And these are the last two sections before we start reviewing for test 3. Newton's method. Okay, let's suppose we have a function that does this. It's not our best friend from all these previous chapters. It's just a function that crosses the x-axis. And I'm going to say that this is the root. R is the solution to this equation. R is the solution, or the x-intercept. So when we set f of x equal to 0, we try to find the x-intercept, and the solution is R, root. The root of this, the solution, or the root of f of x. I'm not talking about the square root or anything like that. It's just the solution of f of x equals 0. Using the using the intermediate value theorem, intermediate value theorem, I can determine an interval, right? The function is continuous. It crosses the x-axis. With the intermediate value theorem, I can determine an interval where the solution is. The intermediate value theorem, as we did it in continuity, we know the intermediate value theorem will not give us the solution, but it will tell us, well, there is a solution between 1 and 2, or there is a solution between 4 and 5, because the function is continuous and changes sign. Right? If it's continuous, it has to pass through 0. Okay. So here's what this mathematician did. He said this. Let's start somewhere. Initial value. I'm going to say that this is my initial value. I want to start here. Let's say the interval is 3, 4, and I want to start with 4. That's an example. I draw a vertical line. It crosses the graph at this point. And at this point, I'm going to draw a tangent line. Everything in this calculus has to be related to tangent or derivatives or rate of change, right? So I'm going to draw the tangent to the graph at that point. I'm going to extend it. I'm going to create a new point, which is denoted by x sub 1. Okay, so the coordinates of this point, I hope you agree, are x0 comma f of x0. Do you agree? I hope you agree that the coordinates of this point are x1 comma 0. Would you agree? This line is the tangent line, and I would like you to give me the slope using these points. I want the slope of the tangent line. y2, yes, minus y1, very good. F of x0 minus 0 over x0 minus, you agree? But there is another way of determining the derivative of this line. There is another way of determining the slope of this line. What is it?
You already said it though.
I know, but I'm still waiting. What is it? At which point? I mean, it's not just the derivative. It's f prime of x0, of course. F prime of x0. Perfect. Do we agree with what it's presented here? Yes? So at x0, I draw a vertical line. It meets the graph in a point. I draw the tangent. I extend the tangent. The tangent will definitely cross the x-axis. And I created another point. From these 2 points, I can determine the slope. And it's also the f prime of x0. Would you agree? Good. What do you think I'm going to solve this equation for? Before you say anything, let me just give you a hint. I started with x0. But using this mechanism, I created x1, which is much closer to the root than x0 is. That would be the first iteration, the first approximation of the root. I started here at x0, but now I got x1, which is closer to the true solution. So what do you think I'm going to solve this equation for? Of course, for x1. I will cross multiply. So I have f of x0 equals f prime of x0 times x0 minus x1. So now give me the next step. All these are known. I picked the initial value. This is known, this is known, this is known. The only unknown is this, which is a better approximation of r than x0 was. So I will have to distribute. So f of x0 equals f prime of x0 times x0 minus x1 times f prime of x0. I'm after this. I will move this term to this side. I will move this term to the other side. And then divide. So x1 f prime of x0 equals f prime of x0 times x0 minus f of x0. Let's stop for a moment and see if this is clear. So after I cross multiply the 2 expressions giving us the same tangent, the slope, the slope of the same tangent, or the same value, I cross multiplied, I got the first line. Now on page 15, I distributed f prime of x0 to x0 and f prime of x0 to x1. Now, because this is what I'm after, I moved it to the other side, and of course I had to move f of x0 to the right. In order to solve for x1, I have to get rid of this. So x1 equals f prime of x0 over f prime of x0 times x0 minus f of x0 over f prime of x0. This is close, not finished. Newton's method. Can anyone give us a shot or an idea of what will happen next? Let me explain. In the next step, I will draw a vertical line. It will cross at this point. I will draw the tangent. I will get x2, which is much closer. I will continue and do that till I get closer and closer to r. So looking at this, can anyone give us an idea of what you think x sub 2 will equal to? Yes, x1 minus. Of course, because now everything is in reference to x1. Okay, and so on and so forth. The n plus first iteration. What will that equal to? Very good. X sub n minus f of x sub n over f prime of x sub n. We're not going to get to n. The method is converging very fast in 3 or 4 steps, depending on accuracy. If you want 50-digit accuracy, it may take 20 minutes. If you want 4 digits accuracy, it may take 3 steps. There are 2 potential problems here, however. One potential problem I cannot start with x0 that makes f prime what? Right, so you have to be very careful. Make sure that you determine f prime first. We're going to look at examples in a minute. Make sure you determine f prime first, and the initial value that you pick does not make f prime 0, because the method will never converge. Here's the second potential problem. Which it's unlikely, but it may happen. If you pick the starting point, this is the solution that I need to determine, and I start here. But if there is a max or a min between these two, the starting point and the actual solution, the method will never converge. Because you're going to stay here, it will never get closer and closer. But that's unlikely, but it can happen. So make sure there is no max min between your starting point and the solution that you're looking for. And also make sure that the denominator, when you plug in, the initial value is not 0. Okay, ready? Now you are empowered with a tremendous tool. Now you are able to solve any equation that you can think of, which was not possible before. And I'll let you choose whatever you want. Any equation. And this is Newton's method. So for example, something like this. No one can solve by hand. There's no such thing. There's no algebra for this. There is no algebra for this. There is no algebra for this. You can't. You can't solve this by hand. You can't solve this by hand. Maybe this is possible somewhat. Maybe this is possible, but these four, absolutely not. But Newton's method will solve that problem easily with any amount of decimal digits, any accuracy you want. So please choose anything you want.
Is that supposed to be sine x equals?
Yes, sine x equals x squared minus 2. Very good. You want to pick that? Perfect. So 22, page 342, and sine x equals x squared minus 2. There are several steps here. First, we don't have an interval. We have to use the intermediate value theorem to determine an interval, which means we have to create the function. Remember, we are trying to solve not this, but this, which is the same thing, but I have to create this. So we have sine x minus x squared plus 2 equals 0, and this is our function f of x. And we can determine its derivative right away. Cosine x minus 2x. I have to write that f of x continuous everywhere as a combo or addition, subtraction of continuous functions. I have to write this. And 2, by the intermediate value theorem, I have to find an interval because I don't know where to start. So let's go to the graphing calculator and let's plug in y equals. Clear. So the function is sine x minus x squared and plus 2. I have no idea where to start, but I'm going to start with small numbers. So I'm going to say plug in second and table. I'm going to plug in 0, which is there already. I'm going to plug in 1. What is doing here? 0 and 1 and then 2. And I'm done so far. That's all I need. I see that this function that is continuous changes sign between 1 and 2. That's all I need. So I'm going to choose the interval 1, 2. And I will pick x0 to be whatever you want. It doesn't matter. If you pick 1, this will not be 0. If you pick 2, this will not be 0. It doesn't matter where you want to start. You want to pick x0 being what? Okay, very good. We create a function. Create Newton's function. Because we're not going to do this by hand. So I'm going to create Newton's function n of x. I'd like to name it n of x, Newton of x, which is x0 minus the function sine x minus x squared over 2 over its derivative, which is cosine x minus 2x. I don't need the 0 there. That will be the first one, of course, anyway. But I created the function of x. This is what I need to put in the graphing calculator. What are we going to plug in first in it? And then we're going to plug in the result. And then we're going to plug in the result. And then we're going to plug in the result. Now we have to decide how many decimal digits you want. You may want 4, you may want 6. Just choose. I don't care what they say in the book. You choose. What is the accuracy level that you want? 4 digits? 5 digits? 5 digits. Okay, very good. 5 is good. So let's put this function in the graphing calculator. Ready? Since you have the function, don't delete. Don't delete. Don't delete. So insert x minus, put parentheses, because this is the numerator. Sine x minus x squared minus plus 2 is the numerator. Make sure that you put parentheses around it completely, and then divide by, in parentheses, cosine x, close the parenthesis, minus 2x. And close the parenthesis. This is the function that we just created, x minus f of x over f prime of x. Now get out of there with second and quit, and go to variables, to the right, function. So variables, to the right, function. Click yes, that's the function I want. Click again yes, function y1, that's where I have my function. And in parentheses I put 1. And I press enter. So make sure that the mode is in gradient mode. I haven't checked. I'll know immediately if there is an error. Because if it goes berserk, if it goes to 2 and then to minus 5 and then to positive 3, we expect a solution between 1 and 2. So if it goes all the way insane, then I know something is wrong. So let's go and let me look at the mode. It's in radian. Okay, perfect. Here's what we do next. We go back to variables. We select the function one more time, as we just did. And in parentheses, we will put the previous answer. We're not going to copy anything. We're not going to truncate any numbers, although we're going to have to write these down. In a minute, we will. So let me write it right now. So the first iteration, x1, was 2.26154. 2. When I plug in the previous answer and I hit enter, this will be our second iteration. Ah, it's getting close. So this is our x2, which is 1.8073344. All you have to do now is just copy the previous entry. Do not do anything. Just copy the previous entry. It will automatically insert the previous number and press enter. Copy again and press enter. Copy again and press enter. We're done. Why? How do I know? because I have 1, 2, 3, 4, 5 digits that repeat. I don't even need this one. This is it. So I had x2, I have x3, 1.730872, and I have x4, and we are done. In 4 iterations, we determine the solution with the accuracy you wanted. You said the accuracy 4, 5, so I even counted more than 4, more than 5. This is the solution. It's an irrational number, so I can't have a 100% exact, but I'm hoping that you are very proud of the accuracy we determine the solution. So I don't want you to truncate those numbers and plug it in, because you introduce error every time you do that. So that's why we are copying. Then he will, in here, he will introduce this. In here, he will introduce this, and we continue with more decimal digits, then you will replace by the next and the next and the next. And this all was possible with calculus. We still have some time, about 6-7 minutes, so let's try another. Let's say 19, and x minus 2 to the second power equals natural log x. So let's work on this. And then we'll stop. Isn't this impressive? And what is impressive, I think, is how simple it is. That's, I think, it's even more impressive. That's why I said Newton's method, it will take us 15 minutes or less. Okay, I'm just making sure that I uploaded the first video, which I did, so I can delete it. Good. Ready? Oh, no one saw that what I was writing. That's why nobody knew what I was doing. I'm sorry. I just took the moment to make sure I uploaded the first video. Okay, so here's our equation. We want to solve it. No one can solve this by hand, but now we can. So you have to create a function, right? So we have x minus 2 squared minus natural log x equals 0, correct? And this is our f of x. And you should right here also determine f prime. 2x minus 2 minus 1 over x. And you should determine or create Newton's method, Newton's function. which is x minus 2 squared minus natural log x over 2, x minus 2 minus 1 over x. And this is what we have to put in. But of course, we have to say that the function is continuous, and it is, on 0 to infinity because of natural log. Do not attempt to plug in 0, because natural log does not exist at 0. So start with 1, right? So f of x, continuous on 0 to infinity as a difference of continuous functions. We know the domain of natural log starts at 0, not 0, strictly greater than 0. And when you put that in the calculator, right, so we have x minus 2 squared minus natural log. And we try to find an interval. So of course at 0 I have an error. Again, I have between 1 and 2. So at 1 is positive, at 2 is negative. So by the intermediate value theorem, you can start anywhere you want, 1 or 2. Okay, very good. As long as the denominator, or f prime, so between 1 and 2, there is a solution. So just make sure that, so if x0 is 1, make sure that f prime of 1 is not 0. And it's not. What accuracy we want? How many digits? You want 4? Very good. So 4 digits. Accuracy. Very good. So we do not delete what you already have, because you already have the function. Just make sure that you insert x minus in parentheses. Keep the entire function in parentheses. It has to be in parentheses. Close. Divide by. Open the parenthesis. And we have 2x minus 4 and minus 1 over x. Or x to negative 1. Oops, I didn't mean that. I know. It just, when I mess this up, everything just collapses. Okay, 2x minus 4 and minus 1 divided by x. And close the parenthesis. So now we go to second and quit, and then variables. We call y and y1, and we put in parentheses 1. And when we press enter, this will be our first iteration. 1.333333. Now the next one, you can copy what you have already, but just make sure you overwrite 1 by the previous answer and close the parenthesis. That's okay. And then again, copy what you have. And then again, oops. And then again, copy what you have. And I see to 4, you wanted 4. We're done. It converged in 3 steps, 3 iterations. So x1 was 1.333, x2 was 1.408579, and x3 was 1.41238. I don't have to continue. How do I know? When I see that the first 4 digits repeat, this is redundant. That's your answer. 1.41238. Any questions?